Section 5.7 is on the natural logarithmic function integration. So here what we're doing is we're doing the derivative. What we know is the derivative with respect to x of the natural log of x is equal to 1 over x, right? Okay, so what we're doing is that rule backwards. So we know that the antiderivative of 1 over x with respect to x has to be the natural log of x, but the problem is if you remember here we had a restriction that x had to be positive because that's the graph of the natural log of x. So we have to make sure this x right here is positive, and the way we do that is by putting an absolute value sign on it. That ensures that we're inputting a positive value. And then of course we have to have the plus c because this is an indefinite integral. So that's the rule right there for the natural log, is just looking at the derivative rule going backwards, and we end up with the rule the integral of 1 over x dx is the natural log of the absolute value of x plus c. We could do the same thing with U-Substitution right there like we did in the previous section. Okay, so those are the rules right there. Just make sure that you remember the absolute value. In fact, let's write a note like that. Let's say must remember the absolute value in the answer. Okay, absolutely important that you remember the absolute value in the answer. Okay, so let's give it a try right here. We have find the integral of 2 over x, and maybe let me motivate this for you. So some of you, I'm going to do this wrong in the first way, and let me show you why. A lot of you would see that you could pull this out, the 2 out, because that's a constant multiple, and you might say this is 2 times the integral of x to the negative 1 dx. And then you might think, okay, let's use the power rule. So this would be 2x to the, well, think about what negative 1 plus 1 is. That would actually be to the 0 over 0. And this right here is undefined, right? So what this is showing, what this is illustrating, what I've just done is illustrating that the power rule does not work. And if you remember, the power rule says that the integral of x to the n dx is equal to x to the n plus 1 all over n plus 1 plus c for all n not equal to negative 1. In other words, it doesn't work for the integral of 1 over x dx. That's the only case where the power rule doesn't work, okay? So that's what we just showed right there, is that it absolutely, the power rule cannot work for x to the negative 1. Just because what we just saw, it would be undefined. So all of this right here is garbage. You can't use the power rule. But let's do it the proper way now. So what this is equal to is, yes, let's still pull out that 2 because it's a constant multiple. We know that the integral of 1 over x is the natural log of the absolute value of x plus c, and we're done. Okay? So using the power rule actually makes this problem more difficult than the actual problem is. So I just wanted to show you, let me just write recall power rule. I just wanted to show you why the power rule wouldn't work and what I see going wrong a lot when I'm grading the tests. Okay, so let's look at this next one here. How about find the integral of 1 over 4x minus 1? Well, really, this is a U-substitution in disguise. So let's remember our steps for one U-substitution. Here we're going to let u equal the 4x minus 1. The second step was take the derivative of both sides. So this is du dx would equal, well, the derivative of 4x minus 1 is simply 4. Okay, step 3 was solve for dx. We know that dx would equal du over 4 using our cross multiplication. Multiply both sides by dx, divide both sides by 4 is what I'm saying. Then we have to do our substitutions. We always substitute in for dx, and we always substitute in for u. And so we're going to move on to the next step, which would be step 4, which is rewriting the integral as 1 over, instead of 4x minus 1, that would be u. Instead of dx, we'd have du over 4. Again, I noticed that that's a constant multiple. That 4 is a constant multiple, but it is in the denominator, so when I pull it out, you got to be really careful. You're pulling out a 1/4, not a 4, right? And this it turns into 1/4 times the integral of 1 over u du. Now, because everything's in terms of u, we can move on to step 5. So this would be 1/4 times the natural log of the absolute value of u plus c. And then our last step for step 6 is just back substituting what u was. So step 6 would be back substitute. This is 1/4 the natural log of the absolute value. U was 4x minus 1 plus c. Right there. How do we know that's our answer? You could go ahead and differentiate. Remember, anytime you integrate, you could differentiate to confirm that this is the proper answer. So think about this. This would be 1/4 times, well, the derivative of the natural log of 4x minus 1 would be 1 over 4x minus 1 times the derivative of 4x minus 1, which would be the 4. So the 1/4 and the 4 would simplify, and you'd just be left with 1 over 4x minus 1, which is the original problem, so this would check. So I just did a mental check of the answer in a matter of seconds, and I encourage you to do it. I actually encourage you to do it on paper rather than a mental check.